And just to clarify what we're doing, we're making a text-to-speech application for central access. And here's an outline of our presentation. I'm going to be doing the intro, introductions, and things of the sort. Also, I'm going to demonstrate our demo, and I'm going to do 2 use cases resulting from that. And I'm also going to make some concluding remarks. Chris, he will be talking about our requirements, and he's also going to be discussing about our use cases and how those use cases fall within our program. And finally, Brian's going to talk about our quality assurance. That entails testing and make sure our client says it's okay, and also about potential risks that we might run into later in our project. And that involves things like deployment, whether a certain library isn't compatible with another operating system, and things like that. So I'm Spencer Graffy. I'm a team leader and lead documenter. And we have Chris Hansen, and he's our lead programmer. And Ryan Bolliard is our lead tester. And our advisor is Dr. Kolderchuk. And our clients are actually Wendy Holden and Marshall Sons. And from last quarter, our original client was just Wendy Holden, but we've actually been talking more with Marshall because their positions have changed, and he's going to be more invested into our project. So our goals are basically, the first one is the same as last quarter, create a text-to-speech application to assist students in reading their materials. But we added another point on there, is that it has to read math, and it has to read it without visual aids. So you can just hear the output without actually having to look at the equation while you're doing that, because we kind of realized that a lot of disability students prefer just to hear the music while they're doing other things like cooking dinner or whatnot. So we want to be able to have a speech output that they can visualize the equation in their head without having to see the actual math equation in front of them. And about our project description, it's a text-to-speech desktop application, and it's written in Python, and we're using a Qt as our GUI framework. And we're going to utilize the content preparation capabilities of Central Access. And Central Access is a large department that makes specific disability accessible materials for its clients. And they actually service clients from many different universities, because we're actually one of the few that actually have a well-developed disability department. And finally, our project is going to aid students that have both print-related disabilities, so things like dyslexia, anxiety disorders resulting from computer use. And also, we need to address students that also have low vision as well, because we talked about last quarter, we only want to make sure our application works for print-disabled clients, but this time we're going to make more of an emphasis on those with lower vision as well. And Chris is going to talk about our requirements and our use cases.
All right, well, in terms of our requirements, our emphasis has shifted more towards the mathematical equations and reading them because of the, revelation that we really need to produce a math reader. Aside from that, we also have to import Word files just for simple usability and we're importing Word files like doc and docx so that the students can use this for the various documents that they will be encountering, because even after this, when they go into the workforce, they will be given work, they will be given docs. Docx is Word files, basically, and it would be helpful for them to have a tool that they'd have useful afterwards. Among the other things is the cross-platform, focusing on Windows and Macs mostly, again, for usability. And navigation as well, so that they can move to different documents and move within those documents. So if they have, say, a 200-chapter book, or not 200-page book with chapters, they don't have to scroll through it, they can just get to the part they need. Optional features, because we may not be able to fit all this in on time, include the speaking acronyms more naturally, just speaking them out as in NAACP and AARP. I also want to remember the last section read so that they can restart this program after closing it. Keyboard shortcuts as another ease of use function. They will be visual. Well, some of the students will be visually impaired, and keyboard shortcuts will enable them to use commands without trying to go through a list or whatever. And as for audit updates, realize that this program is probably going to have to expand to include other more acronyms, more definitions for MathML and other things. We want to be able to update it automatically, and even if this needs to be replaced, we want to be able to update it that way. Alright, well, for the first use case, we want to import and read a selected book. Got a sample. Just open up the menu to select to import a particular document or whatever. It will play until, and it will stop when you want it to stop, and that's basically it. As for the second use case, let's say a student wants to memorize a particular math equation, like, say, the quadratic formula. They will import the math book which it is in. You can then highlight the math equation and set it to loop repetitively as a method of learning the equation. The third use case, the settings will help make our program a little more friendly. One of the main ways is to just go to the settings menu, add text to the text area if you want a particular text, otherwise there will be a default text in there already. And as you go through it, testing it, you can adjust the sliders to affect rate and pitch. Rate probably being most important. Different books require a different rate due to the density of the material. You can also change the voice to something that might be more pleasant, more easy to remember even. And of course, the testing button to test that.
And I'm going to go ahead and do the demonstration. And basically the two things that we talk about are the player functions and also kind of the in-progress demonstration of our MathML parser. All right, there we go. So I'm going to demonstrate the player functions. So basically what we got here, as you see on top, here's our play buttons. And here is our screen with the actual content. And as you can see, there's a title up here, and there's a first heading down here, and there's a slightly smaller second heading. And they do these headings a lot so that afterwards we can use that for a page navigation as we move further along in our implementation. And luckily there is also a renderer for these math equations. And eventually, once we figure out how to just set this by default, you can just hover over this. And unfortunately that's in white. But it would show the text in a larger format, which is nice for disability purposes. And we also got the speech function to work correctly, so here's just a basic test, and we're just going to read this part right here.
Section 3.3, increasing and decreasing functions in the first derivative testimony.
So we can also change the voice by just pressing on here, and it'll just kind of loop through the different voices that are in there. Later on, we'll have a configuration page for it, but this is for debugging purposes. So when I click on that once, it'll switch to a girl voice, and read that again.
Section 3.3, increasing and decreasing functions and the first derivative test.
And we also found a way to change the rate of the voice. So if they like to have it read back to them a little more slowly and more carefully. So I'll probably just make this pretty short. So you can make it pretty slow if you want to. And it's kind of fun at the same time. But say if you want, yay slow.
Applications of differentiation.
So for those who memorize what is said there a little more slowly, they can do that. Or, if you just want to get through something faster, you can just...
Applications of differentiation.
So you can just do the max, which is 200 words per minute. And, that's fast for normal talk anyway. But so that's basically it. We tried to get the replay to work. For some reason, didn't like the replay for us. And the stop button also works.
Determine intervals on which a function is...
So it stops immediately. The only problem is that once you try to play again, for some reason, we don't know why it's not doing that. So that's our basic player functions. And just to demonstrate how our content will look like in our program. And I'm going to go ahead and right here is kind of almost my brainchild, I guess, of how to parse MathML and to kind of convert it into a text string. And right now it doesn't output that quite yet. Anyway. So up here, there's 5 stages for MathML to be parsed into a string. The first is converting the MathML into a DOM object. And as you can see here, it's basically just the XML, but this time it's in memory. And then after that, I actually read from a database what our patterns are, so that we can later on pattern match them. And I'll show you what that configuration file looks like. So obviously it's commented a lot because we want this to be a point of future maintenance. We don't want them to go into the Python source file and try to figure it out and then make the changes. So basically how MathML parser works is that there's a specific pattern. So right over here is our XML pattern. So right now it's just a literal, and that's a Unicode for a plus and minus sign. And then once it finds that, it'll replace that with a variable called plus and minus, and this is the output text that will look like. Now, as it gets more and more general, as far as speaking what fractions are, down here, here's a MathML mfrac, and that just means fraction. And in these 2 here, the question mark means you can put whatever kind of MathML or object or something like that. And most likely they're going to be m rows. That's usually how fractions are implemented. So then it stores that as a fraction, and then over here is the output text. And you can see down here is that in curly braces there's a 1 and a 2, and those refer to the question marks and whichever other variables you have in here. So whichever output those question marks or those variables output as text, they will be replaced in here where you see the curly braces. So essentially, it just reads through each pattern and then replaces that from the replace tree, and then future patterns can potentially use those patterns in order to create new patterns. So right now, it's just kind of a few things right now. It's still kind of under testing. But that's basically how our math parser works. So it generates a tree, and then from that tree, we have to use hierarchical regular expressions, and then it combines those down to single elements, and it keeps repeating until we get a single tree element that's a speech object, and then we extract the text from there. So that's basically our demonstration. And Brian's going to talk about our quality assurance and risks that we might encounter.
As of right now, to ensure we're making a quality project for the client, we are employing several different quality assurance methods. As of right now, we have the approval of the client of our current layout, so layout is not an issue for us. We also have several of the sample textbooks we will be using by the client in order to ensure our program is able to function with the textbooks that the client uses for these students with visual disabilities. These include several that they have to parse on their own using, right now it's DAISY, in order to get them able to be read. in a reader. We want to prevent this conversion factor. We want to prevent the converting because that wastes numerous hours just to get the program to actually read it, and that is if it fully compiles. An estimated $5,000 is spent on every project just getting it converted in order to be read by Daisy. We're using a structured ad hoc testing for our current program testing, where we just implement a feature and then test it immediately to see if it's functioning, along with the basic functionality is still there. When we complete our MathML part, we are going to pass this program, the shell program, to the client to make sure it can be installed correctly and that it functions according to what they feel it should run as. The client has several technicians that she will pass the program to in order to get more users testing it, and she's going to pass it on to a few of her visually impaired users as well later on in the program. We currently, Spencer has a test suite of MathML equations that he's using to test his MathML tree in order to make sure it is parsing correctly. We also have a textbook that lists various math equations and how they should be read by a teacher. A few of the risks that are specific to our program include the Python library not compatible on Macs. As of right now, the text-to-speech module we are using is PyTTSX, which we also had to download an additional Win32 module in order to get it to actually speak text. In the future, we wish to implement the modules automatically, so it'll install a Mac module or a Windows module or maybe even a Linux module based on what system you are using as a select which one you would like to download option. As of right now, we're also encountering problems with installation. As I said, we needed a Win32 to actually read text, but we also needed to install several different modules manually in order to get it to work. We're going to automate this process for the client so the people who do not have much experience in computers are able to use and install this program. And as Spencer mentioned, we must allow the client able to update the database with MathML and acronyms in order for the reader to properly read future acronyms and changes to the MathML format. In order to prevent the user from not knowing what to do and future frustration for them, we're trying to include these in separate, easy-to-read files such as Excel or a separate Python file in order for the client to be able to go in, easily read what is currently there, and able to add and remove current acronyms in MathML. Now for the conclusion, we're going to Spencer.
So just to clarify what kind of goal we're kind of reaching for, Central Access has required us to create a quality of math reader. Now, there's all sorts of text-to-speech readers out there, and they have seen them all, but unfortunately, they all can read all these different formats just kind of in a mediocre way. So we want to be able to read these math books, have the correct punctuation so that it pauses at the right times, and also have something that reads math rather efficiently in a way that colleges would say it. Now, MathML parsing is possible. I do have a 5-stage plan for it. Right now, I'm on like half of stage 4, and I still need to figure out the regular expressions part. So it is possible. We just need more time for implementation so that we can get the tested up and running. Also, the math that is used in Word files is called OMML, and we initially had a problem with that. It's like, wait, how do we convert this OMML to something MathML, which is something that we understand? Fortunately, there is a XML style sheet that can translate that OMML to MathML for us. So luckily, that problem has already been solved, which is pretty nice. Now, our future priorities that we're going to be completing by the end of this quarter importing doc files is definitely important. As Chris mentioned earlier, people who go out into the workplace, they're not going to be given, prepared math daisy files that have been put in $5,600 of work into there. They'll just be given Word files, from their employer and whatnot. And if they want to be able to read them, then we want to be able to give them that chance. So our reader hopefully will go beyond just a collegiate level, and they can just carry on with them as they go on into the workplace. Finally, we want to be able to incorporate page navigation and also bookmarking as well. So if they go to a section and they find a certain part that they know that's going to be on the test and they have to study for later, they can just go ahead and bookmark it, and then they can save it in their tree. And it's also nice that in large textbooks that they prepare for, it would also be nice to have a page navigation where you can click on a specific chapter, and then it'll just automatically scroll right to that chapter. Fortunately, our content view is all done in HTML, and it supports cascading style sheets and also anchor points. So we would just implement the navigation by specifying the anchor points at different heading tags, and then when you click on that link, it'll just go right to the anchor tag. So that's basically it. Do you guys have any questions for us?
Okay, I have a tricky question. Can you also translate?
Like from a different language?
Yeah, for instance, I want to, I see a text in whatever, Spanish, and I would like to have this loudly translated into English in real time.
Well, that's kind of like on the periphery right now. The formats that we're reading right now are Word files that have been specifically created by Central Access, our disabilities department. And we're kind of just catering to their production process. So I don't know if translation will be a part of it either. For instance, if there was, a Spanish book and it just automatically translates everything, you kind of just end up with an English book. So I don't know if we're going to implement that. It wasn't part of our client's priorities. So
my problem is not if this was on your to-do list. My question is, if you think it is feasible, if you could make it, and how you would proceed?
I imagine it would be feasible. And if we did do something like that, we would probably use a web service, probably Google Translate, and then just feed the text into there, and then get the text in a different language. The only problem is that you would have to have a voice already installed on your computer that can read that particular language correctly. So if you're reading, Japanese and you don't have a Japanese voice, you're not going to get anything from an English voice trying to read that particular one.
It'll just be gibberish.
Yeah, so...
This is for an American user. I mean, you have to translate this into English, not into Japanese.
So in that case, the voice wouldn't be an issue. But yeah, we would have to use an online service for it to be, somewhat reliable. I don't know of a particular Python library that could do the translation. So did that kind of answer your question?
Yes.
So, we could, but, we kind of wanted...
Yeah, I would like to know more details if you think it's feasible in terms of execution time. How fast it would be. Because everybody knows Google Translate.
Well, it definitely would be slower. Because right now, I have to, think about, just for translating the different math equations, I imagine we'd probably have to parallelize that, especially if the document's thousands of pages. We would have to, figure out which section we are in, and then for the parts that we needed to translate to different text, which could be language that's from, a different language, mathematical equation, things of that sort. We would have to precompile that into speech output so that it would make sense. So either way, we would have to put that on a separate thread, just to make it run efficiently. But using a web service would definitely slow down parts where you need to convert from one language into another. Any other questions?
You brought up that you wanted to auto-update. Could you specify more what that means? Like, are you going to be designing updates or a future senior team? Or do you mean something like a database that you're accessing, when it updates, it will update on your project as well?
Ryan knows a little bit more about that.
What the client is asking for when it's specifying auto updates is they want to be able to update their Excel sheets of the acronyms and the MathML stuff automatically. So when they make a change to the acronym database, they'll automatically ask the user, hey, there was a change to this database. Do you want to update your current files in order to match the clients? So they would not be changing source code. They'd be just maintaining their databases, and the users would just have to pull from those databases.
Okay, thank you.
Yeah, the program would just pull it, the server, every time for a newer version number. And then if the version number is newer than the one that's currently on there, they'll, I imagine, just download it as a zip file and then extract it and then replace all the different Python files it's involved with. And then on next restart, it'll be the new updated program. So, any other questions?
All right, thank you.
John has one.
Is there any sort of tab ordering for the controls of the interface, or?
We would like to have keyboard shortcuts. Tabbing would be one of them. So, because a lot of disability students, what they like to do for, the menu bar up there, they would just press Alt and then F or File and then go down. So we would have to support that. But
Was, the play, the pause and stuff, not inherently any sort of normal control to those. So.
yeah.
It's going to read off what they're on, or with those non-standard controls.
So if they have any highlighted text, it'll read within the highlighted text. If there isn't anything highlighted at all, it'll go to the end of the last highlight they did, or the position of where the cursor was before, and then it would just start, and then it would go to the end of the document. And if they were to select, within their, MathML, the MathML will be converted into a string, specifying what the equation actually is, and then it would just redo that. Did that answer your question?